So, hello students. Now, in this revision session, we'll look at more revision content like related to trigonometry and also exponents. All right. Let's say uh, I'll give you a question like this. For this, you need to know about the Pythagorean triplets. You need to be very good with your Pythagorean triplets. So, you better memorize them. If you know the triplets, you'll be able to solve these problems easily. So, otherwise, you lose some time with workaround. That is, you'll be trying to find the third side or the other two sides. And so it's better if you know the triplets, you can easily solve them. Let's say this side is 50, the hypotenuse, and one of the sides is 40. Of course, I've not drawn them to scale. And this is angle theta that I marked here. So you can see here. So let's say the question is from the figure. So it's a figure-based question. You can get these types as well. Find sine theta, find cos theta, and find tan theta. So we can easily find sine theta because we have the hypotenuse and we have the opposite side, because sine by nature is it is sine is opposite by hypotenuse, right? Sine is opposite side upon hypotenuse, or as you know, it's perpendicular by hypotenuse. Some of you will be familiar with this particular version. Cos is adjacent side upon hypotenuse or the base upon hypotenuse. So that is leaving the hypotenuse, the other side becomes the adjacent side. Let me name them A, B, C. Okay. Tan theta will be sine upon cos, or you can say the opposite side over adjacent side, or perpendicular over base. So if you know the Pythagorean triplets, and if you know the definitions of sine, cos, and tan, it's very easy to find all the ratios. They've asked sine, cos, and tan. So sine theta will be opposite side, that is AB, upon hypotenuse. That will be 14 upon 50, or 2 sevens are 225, 7 upon 25. Now, if you look at this, it's nothing but the blown up version of your 72425 triplet, isn't it? There's a triplet where there is 7, then there's 24, and then there's 25. They are blown up by a version of, by a factor of 2. Yeah. So 25 2s are 50, 7 2s are 14. So in other words, 24 2s are 48. So BC will be 48. And then I can find out all the other ratios. I can find out cos theta. What is cos theta? The adjacent side, the neighboring side. Adjacent means neighboring. Leaving the hypotenuse, what is the other side of theta? BC, which is 48 units. Hypotenuse is 50 units. So it becomes, it's going to be 48 upon 50, or to simplify it, to 24 upon 25. And tan, of course, it's straightforward, opposite over adjacent or perpendicular upon base, which happens to be 14 upon 48, which will be 7 upon 24. Okay. So for this, remember, not that you're going to get the same thing, but you must know the triplets. So let's just recap the triplets. So it will be 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, going on, 9, 40, 41, 11, 60, 61, 12, 35, 37, 16, 63, 65, 20, 21, 29, and there are many more, but I told you these are handy triplets. It's good that you know them. They always refer to, or that is, whenever you have a triangle of these sides as the ratio or a combination of these, either the blown up or the blown down or the ratio themselves, then it will be a right angle triangle. It has to be a right angle triangle. So it has to be a right angled triangle. So if you have, let's say, one side measuring 60, the other side measuring 63, and the other side measuring 64, it will not be right angle. If you have 16 and 63, the other one has to be 60. That is the condition. Only then will it be a right angle triangle. Now coming to other criteria, like let's say I give you a question like, what is the maximum value of sine theta? Note that sine theta, I've discussed this in class, sine theta cannot exceed 1. The maximum value of sine theta is 1. Similarly, the maximum value of cos theta, the maximum value will be 1. They cannot exceed 1. But I told you that yes, secant and cosecant, they cannot come below 1. They'll always be having 1, values is 1 or above 1. And coming to tan and cot, they're unbounded. So you must be careful that your sine and cos will always be proper fraction, or the value for sine and cos cannot exceed 1. Then you can also get MCQs on topics and concepts like reciprocal relationships. Now I told you how to remember reciprocal, right? So you have, I told you teacher, cot, teacher is for tan, the sincere cosecant, I'm just writing the abbreviations, causing the security issues. So it's just an acronym to remember. Tan goes with cot, reciprocal, sine goes with cosec, and your cos and secant are reciprocal relationships. So which means when I multiply tan and cot, I'm going to get 1. Tan theta into cot. Same angle, of course. I can't say tan 30 into cot 40. If I say tan 30 into cot 30, then it is equal to 1. The same angle should be there. Similarly, sine into cosecant. Sine theta into cosecant theta will be 1. And what about cos theta into secant theta? That will also be equal to 1. Sine theta into cos theta will be secant theta into cos theta into secant theta is 1. So you should know the reciprocal relationships. Tan and cot are reciprocal ratios. Sine and cosecant are reciprocal ratios. And cos and secant are reciprocal ratios. So when you're given a question, you should be able to solve. Then coming to factorization, coming to our a square and b square. What if I give you a sum like 73 square minus 72 square? Okay, see, now this is an MCQ and you should do it as quickly as possible with minimal options. So I can give you some big numbers, A, B, C, D. And you might sit and do multiplication. 73 into 73, 72 into 70. None of that is really required because you use the relation A square minus B square is A plus B into A minus B. A minus B is 73 minus 72. A plus B is 73 plus 72. That happens to be 145 into, this is 1. The answer will be 145. So be very careful when you solve for these kinds. You're not going to actually go and do the long multiplication. It's not worth it because you are using the property. You're using the property of factorization that a square minus b square is a plus b into a minus b. So another typical question can be 81 to the power of x is equal to, let's say, 243 to the power of 2y, for example. And I cannot find what is x and what is y, but of course, I can ask you what is the ratio of x's to y. So we need to reduce everything to a common base. We know that 81 is 3 to the power of 4. Okay, write that. And we know that 243 is 3 to the power of 5. And we have 2y here. So when we use the technique that, what have we used? 3 power 4 is 81, 3 power 5 is 243. So remember, a to the power of m to the power of n is a to the power of m into n. So likewise, it is 3 to the power of 4x is equal to 3 to the power of 5 to the 10y. And now you can say 4x is equal to 10y. So you bring the x down. x upon y is 10 upon 4. 2 5s are 2 2s are. So in other words, x is to y is 5 is to 2. In ratio language, yeah. If they mention ratio, you have to mention it as it will be 5 is to 2. So you'll be very careful when you're solving problems of these types. The absolute value is not important for us. We just interested in the ratio. That is how x and y are related. Okay. Then you should be knowing factorization of square trinomials. For example, if I give you x square minus, let's say, 10x plus 25, small example. You can factorize it, but you can also identify this as x square minus 2 into x into 5 plus 5 square. Isn't it? That will be a square minus 2ab plus b square. If you look closely, x is like a here, b is like 5. So what is x? A square minus 2ab plus b square? It is a minus b the whole square. So in this case, it will be x minus b is 5, no? X minus 5 the whole square. Okay. So in MCQs, if you're getting something like this, you should be able to identify the square trinomials. I can ask you 4y square minus 12y plus 9. So I can write 4y square as 2y the whole square minus 2 into a into b. b is 3. 2 to the 4, 4 3s are 12y. I'm going to get this, isn't it? 9 is 3 square. Same thing. A square minus 2ab plus b square. A is like 2y and b is like 3. That will be a minus b the whole square, which will be 2y minus 3 the whole square. Yes, there's one more formula involving cubes. We say a plus b plus c is equal to 0. Then a cube plus b cube plus c cube is equal to 3 into a into b into c. Okay. For example, if I have 8 cube minus 5 cube minus 3 cube is equal to what? I'm not really going and solving. I can write this as 8 cube plus minus 5 cube plus minus 3 cube. I can shift the minus in. So it is of the form a cube plus b cube plus c cube, isn't it? Where a is what? 8, b is negative 5, and c is negative 3. So what is a plus b plus c? A plus b plus c will be 8 minus 5 minus 3, which is 0. So if a plus b plus c is 0, you can infer that a cube plus b cube plus c cube will be 3abc. So in this case, 3 into 8 into negative 5 into negative 3. So what will that be? 3 into minus 3. Minus into minus is plus. So it gives you plus. The final answer will be plus. 3 3s are 9. 8 5s are 40. So it is plus 360. So if a plus b plus c is 0, if a plus b plus c is 0, the condition that we get is a cube plus b cube plus c cube is equal to 3abc. Okay. You can also expect problems based on these types. Then the other type is, you need to know, if I give you x plus y is equal to, let's say, 11 and x into y is equal to 28. Simple. I mean, at first sight, it's not obvious because 28 has several factors. 14 2s are 28, 7 4s are 28, 28 1s are 28. If you look carefully, you'll know how to break up the factor tree. I know that 7 4s, I'll go with 7 4s because 7 and 4, when I add the components, I'll get 11. When I multiply, I'll get 28. So a typical question can be find, let's say, x square plus y square. They're not even asking what is x and y. So you can say 7 square plus 4 square. Let's say 49, 4 4s are 60. So which will be 65. Okay. So this is an example. So when you can expect like the sum of two numbers is given and the product is given, the numbers themselves explicitly are not given, but you'll have to compute x square plus y square or x cube plus y cube. So you should know the conversions. So it's always good to know this identity is an expansion because you're going to solve them, and it's also helpful from grade 10 point of view. So know your identities, list them out once, so it becomes easy. And then you'll be getting questions where you can get factorizing by splitting the middle term. When nothing is mentioned, you can use any technique. But when they specifically say splitting the middle term, you'll have to go with splitting the middle term. If I say x square minus 5x plus 6 with the middle term, you know it. X square minus 3x minus 2x plus 6. You can come, then you can club once you have split, you can use your grouping technique. X into x minus, across the first group, x is common. Take out minus 2, you can write 6 as 2 into 3. So for the second group, take out 2 common. So your x minus 3 is a common factor, x minus 3 into x minus 2. So this is another method of solving, okay? X minus 3 into x minus 2. Then you can also get questions where you'll have 3x square plus 19x plus 20 and solve by splitting the middle term. So in this case, again, it's of the form ax square plus bx plus c. So what is 3 into 20? 60. So look at the factor of 60. 6 tens are 12 fives are 15 fours are 30, 32s are. There are multiple ways, 23s are, but we want that group or that branch which will give me 19. The middle term is 19. A into C is 3 into 20, which is 60. I want B because see when when we add the factors of AC, I should be getting 19. So 15 fours is 19. Let me split it up as 3x square plus 15x plus 4x plus 20. I split the middle term 19x as 15 and 4. Then group them. You can take 3 common and x common, x plus 5. And likewise here also, you can take 4 common, 4 5 is x plus 5. So now if you solve, you can take out x plus 5 common into 3x plus. All right. So up till here, children, I think it's sufficient. So go through the revision content. If you still have doubts, reach out. I hope you'll be able to understand. Follow the revision content. I've also shared from the previous 2 videos. Go through it and I hope you'll do well. Okay, all the best.